This is number 1 for the practice test for Chapter 6, also the Semester 1 final. So we've got a 1,320 kilogram cannon, fires an 11 kilogram cannonball with a speed of 480 meters per second. I want to know the recoil velocity of the cannon, and I'm assuming that everything started from rest. So the trick here is that there are no external forces, and therefore the total momentum before and after the explosion must be the same. So I'm going to draw a before and after picture. So before, okay, I've got the cannon. Let's see if I can draw a cannon. Cannon with the wheel. Yeah, okay. With the cannonball in it. And nothing was moving, so the total momentum was simply 0. But afterwards, I can't write. Afterwards, the cannonball, just the cannonball, is moving with a speed of 480 meters per second. The cannonball has a mass of 11 kilograms. The cannon, now by itself, that looks stupid, sorry, okay, is doing something backwards. I just don't know what. I don't know how fast it's going. But it has a mass of 1,320 kilograms. Now, if I'm going to write out the total momentum of this picture, it would be the momentum of the cannon plus the momentum of the cannonball. Well, I've got, this is going backwards, so the momentum of the cannon would be the mass of the cannon times negative v, since v is going backwards, it would be a negative number, plus the mass of the cannonball times the velocity of the cannonball. Okay, and that has to equal 0 because the total momentum started off as 0. The total momentum must end at 0. So what I have here is 0 equals negative 1,320v plus 11 times 480, which is 5,280. 5,280. Okay, and I just have to solve for v, so that needs to go over there and then divide by 1,320, and I end up with a final velocity backwards of 4 meters per second even. That is the recoil velocity. Technically, we should have a direction on this. It should be opposite the cannonball, but that's kind of implied in the question of what is the recoil velocity. Because it's been named as the recoil velocity, we already know that it's backwards. If you want to, though, you could throw in backwards. However, I'm not going to dock you points if you don't do that. Speaking of points, let's talk about points. Okay, well, the big thing here is somehow showing me that the momentum before and after is the same. So either it's you just write it as the same number in the before and the after, or they're just on, you write it out, you just straight up just say PT equals PT, or PT doesn't change or something. That's really, really important, so I'm going to give you 2 points for that. For finding the initial momentum to be 0, there's a, how about a point? For somehow expressing the momentum of the gun as 1,320 times v, do a point for that. For somehow expressing the momentum of the cannonball, get another point for that. Let's see, for getting proper, the actual answer, let's see, what are we up to? 2, 4, 5. Let's see. Let's do 2 points for the answer. Let's do 2 points for the units. 2, 4, 6, 8. Oh, I need another point. Let's go for also showing that the either showing that the total momentum is 0 before and then showing it again as after, or if you just do it once, it'll give you 2 points. In fact, that's probably easier. We're just going to do that for recognizing that the total momentum needs to be 0, either by putting it here or by putting it over here. Either one is fine.